Morning guys, today we're going to be talking about 10.7 angles related to circles. So this is where we're going to jump into a lot of the math dealing with circles. What you guys will be learning, I can find various angles on and within circles formed by tangent lines, secant lines, and chords. Now in our last video we went over what tangent lines are, secant lines are, and chords all are. Today we're just going to be expanding upon that a little bit and seeing what they'd look like if we saw multiples of those within one circle. Alright, so first off, some definitions for us. When the vertex is at the center of the circle, so we see that we have this angle here, angle XOY, and we have this angle that's formed at the center of the circle, because O is the center. We call that a central angle. So angle XOY is a central angle. Now, the measure of the central angle, so the measure of angle XOY is going to be equal to the measure of the arc that it's facing, the arc that it's intersecting. So we see that these 2 points, X and Y, this is the arc that's being intersected, arc XY. Because again, these two lines that form our angle are cutting that circle at point X and point Y. So this is our equation. Our central angle, if it's formed at the center, it'll always be equal to the measure of the arc that it's facing. All right. And again, this is the same exact thing. Central angle is found at the center of a circle, which we can see right here. And then also, it's equal to the arc that it's facing, arc XY in this case. So that's what this symbol stands for, is the arc, the measure of arc XY. And again, arcs will be written in degrees as well. So we're dealing with degrees within a circle, and of course we know that there's 360 degrees in a full circle. So we're going to keep that in mind as we go through these. Next, here's the equation that we'll use when our vertex is on the circle. So if our vertex of our angle is on the circle itself, it's lying on the circle, as we can see with point R and point H. That means that our angle, in this case of number 1 up here, the measure of angle R is equal to 1/2 the arc that it's facing. So in this case, 1/2 the measure of arc QS. So it'll always be 1/2 of the arc that it's facing. So an inscribed angle is an angle found on a circle's edge. That's what we call this angle here, an inscribed angle. The inscribed angle is equal to 1/2 of the intercepted arc. QS is our intercepted arc. So the measure of angle QRS is equal to 1/2 the length of arc QS. All right, next, if it's tangent chord. So as we can see here, we have a tangent. Line segment HI is a tangent line. And then we have a chord here as well, HG. So this is a tangent chord angle. It's formed by a tangent and a chord. So this angle here, the measure of angle GHI is equal to 1/2 the measure of the arc that's facing. Well, the arc that's facing is this arc here. What's the name of that arc? Well, it's arc HG. So whatever arc it's facing, whatever arc it's intersecting at, it's equal to 1/2 of it, as long as it's lying on the circle. So again, we saw if it's in the center, it's the same. If it's on the circle, it's 1/2 of the arc that it's facing. All right. Next up, if the vertex is outside of the circle. So this is where we start talking about various different types of things that we're going to be seeing, these two different formulas. And this is where it starts getting a little bit more complicated, but as long as you pay attention, it's not too bad. So, looking at all of these, one thing that they all have in common is they all intersect. The vertex is found outside the circle. Now, if that's the case, the measure of the angle, and I'm just going to focus on this first one here, the measure of the angle, so the measure of angle ABC is equal to the measure of arc 1, so arc AC, minus the arc 2, which we don't have a name for that, arc 2, Whoops. So I'll just call that arc 2, the measure of arc 2, divided by 2. And that's how we can find these. Now, let's go ahead and see what this looks like. So for this first one here, if we're going to name it based upon what we have. So this segment here, well, that'd be a chord, and this is a chord. So we have a chord going on here. So if we see two chords and they don't intersect except on the outside, then we're going to use the 1/2 arc 1 minus arc 2. So anytime that they intersect on the outside, the vertex is on the outside, we're always going to do subtraction. Always subtraction. Now along with that, it's very important that we do big arc angle minus little arc angle. We shouldn't be getting any negatives for these answers. And if you do get a negative, you mixed this up. You did big angle and little angle. You got those mixed up. So if you're getting negative answers, just flip these around and you should be good to go. So with the second one, what we have, angle R is a blank. Well, looking at this, RQ is a chord. RS is a tangent. So this would be a chord tangent. And again, we do the same exact formula. Measure of angle QRS is equal to 1/2 of arc 1 minus arc 2. And that's all we got to do for these. Then the last one, well, XY is a tangent. YZ is a tangent, so this must be a tangent. If you see any of these three where they intersect on the outside, where the vertex is on the outside, always subtract. It's on the outside, always subtract. The reason I say that, and the reason I'm trying to make it very distinguished with what you're doing, is because what we'll see on the next one. And again, here's the formula for these problems. So make sure that you guys get these formulas down. So, vertex is inside the circle, not at the center. If it's at the center, we already know that's equal. If it's not at the center, we see the intersection on the inside. So if angle is inside and chords intersect, well, angle ACB is chord. ACB is chord, because again, that's just two chords. This time, if they intersect inside, if it's inside, we add. So arc 1 plus arc 2. Now, if we're adding, it doesn't matter which goes first, big or small, because we're adding. For subtracting, order matters. So just add your two arcs together, divide by 2, and that'll give us our angle. So let's actually do an example of these. Find the measure of the indicated angle in two different ways. So go ahead and try this one out if you'd like on your own, and then I'm going to go ahead and go through it now. So, way one. The first way that I went ahead and solved this is I found this green angle right here. And since this forms a straight line, OQ is a straight line, I can use supplementary angles to find angle X. So if I do it this way, the measure of this green angle is equal to the arc that's facing, 70, plus the arc that it's also facing, 90, because if we see this, these chords are intersecting these two specific arcs, so I'm using 70 and 90 because they're being intersected, and then I divide it by 2. 90 plus 70 is 160, divided by 2 is 80, so this green angle here is 80. If the green angle is 80 and it's forming a straight line, I can do measure of angle X is equal to 180, our straight line angle measurement, minus 80 degrees, giving us the measure of angle X is equal to 100. All right, let's try and solve this another way. If you can think of another way, go ahead and try it out. I'm going to go ahead and get started on that now. So, our second way. Well, the first thing I'm going to do for our second way is I'm going to find the measure of arc MQ, which I labeled as Y in this case. So I have 90 plus 80 plus 70 plus Y equals how many degrees are in a circle? Well, 360. This gives me 240 plus Y equals 360, so Y is equal to 120. So that means that if Y is 120, then I can now use this equation right up here, because again, they're intersecting inside, to find out what the measure of angle X is. So this will give me 120 plus 80 divided by 2, which is 200 divided by 2, which is 100 degrees. It's the same exact answer that we got before. Two different ways to solve it. Both ways work perfectly fine. All right. Next, go ahead and try this one out. I put up some questions for you guys to ask yourself beforehand. These are the questions that you guys should be thinking each time. So what do we have? Do we have chord tangent, 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 chord, chord? What do we have to get started? Next, do these intersect? Well, yes, they intersect on the outside of our figure. So I know that AC is equal to 100. AC is equal to 100, and we know that BC is equal to 120. BC is 120. We want to find out measure of angle D. So, if the angle's on the outside, which equation would we use? Well, if it's on the outside, we should use arc 1 minus arc 2 divided by 2. So, let's go ahead and do this. First thing I need to do is I need to solve for arc AB, this arc right over here. If I know that's 220 overall, I can do 360 minus 220, and that'll give me a 140 degrees. From here, we can do 1/2 of 140 minus 100, again, big angle minus small angle, which will give me 1/2 of 40. Well, half of 40 is 20 degrees, so the measure of angle D is 20 degrees. That's all we have to do for these. So again, very important that we know what each arc is equal to, we know which equation we're dealing with, and we know how to set it up. If we can do all of those, then we're good to go with this. All right, try this next one out. Find arc AP. Here's the questions that we'll go ahead and start with. Which equation should we use? What questions are useful? Can I manipulate equations to solve for arcs? Well, let's go ahead and answer those. For our equation, again, we have an intersection inside of our circle, so we should be using the plus equation. So the measure of angle 60 is equal to 1/2 of AP plus OS. Which questions are useful? Well, what do we have? In this case, we have chord, chord intersecting on the inside. Where do they intersect? Again, on the inside. And where is our angle? Well, what we're trying to solve for is this arc over here. So we're trying to solve for AP. So I'll go ahead and label that as X for now. Then lastly, can I manipulate equations to solve for arcs? Absolutely. We can manipulate any equations that we'd like. So if you want to manipulate it to solve for an arc, you definitely can do just that. So here's my work. The measure of angle ARP, I just called this intersection point R, just so that I can name it, is equal to 1/2 of AP plus OS. Well, we're trying to solve for AP. That's our goal. So I now have 60, which is angle ARP, is equal to 1/2 of arc AP, what we're trying to solve for, plus 40, which is OS. And again, I knew to use those because our chords are intersecting those arcs. So from here, I can go ahead and multiply both sides by 2 to get rid of that 1/2, and I get 120 is equal to AP plus 40. I subtract 40 from both sides, we find out that arc AP is equal to 80 degrees. So AP is equal to 80. That's all we have to do for these. So again, use any of the equations and then plug in for your missing one, solve for your missing one from there. All right, try this one out. This one's a little bit more difficult. Find angle KPN. I have a tip right down here for you guys for these types of problems. Start labeling everything you can on the circle. Look for diameters and tangents. And we also know that circles add to 360 degrees. So knowing that we have a diameter, a tangent, radius, chords, stuff like that, extremely important for us to know these. All right, I'm going to go ahead and get started on this one. So first off, looking at this, we have chord, chord. Once again, it's intersecting on the inside. So I should be using plus. So again, inside circle is equal to adding them, and then again it's chord. So now we have the measure of angle NPM is equal to 1/2, and again that's what we're looking for, NPM, or sorry, we're looking for KPN. So I'm using NPM to get started because those are the angles that I have that the arcs are facing. So if I can find NPM, then I should be able to find KPN. So NPM is equal to 1/2 of NM, arc NM, plus arc KL. That'll give me 1/2 of 100 plus 30. Well, 100 plus 30 will give me 130, and half of that is 65. So NPM is equal to 65 degrees. But I also know that we have a straight line here. So from K through P into M, that creates a straight line for us. I know that there's 180 degrees in a straight line. So I can use the measure of angle KPN, what we're trying to solve for, is equal to 180 minus 65. And that'll give me 115 degrees. So the measure of angle KPN is equal to 115 degrees. All right, that's all I have for you guys this week for videos. Your homework is available on Schoology. If you guys have any questions, please let me know. Other than that, take care. Thank you guys for watching, and I'll talk to you soon. Bye.